Hi, this is Dr. Tom Kessler. This is the lecture on time series analysis and forecasting. Hopefully prior to listening to this lecture, you've listened to the prior lectures that I recorded on simple and multiple linear regression. I would say that many textbooks don't do a very good job with this topic. Certainly if you're using the Winston, Zapp, and Albright text, data analysis and decision making, certainly that's the case. The chapter 12 in that book is extremely dense and difficult to get through, and it really needn't be given the importance of this topic. The idea of time series analysis and forecasting is a very important one. It's very useful for us to examine observations over time, things that have happened like last year, the year before, and as recently as this year, and be able to say, based on that data pattern, I can tell you what that data is likely to look like this fall and next year and the year after. So this idea of being able to look at a single piece of data, a number of observations of that data, over time, and to be able to use the trends that you're seeing over time to be able to forecast those values in the future. The Federal Reserve, I worked at the Federal Reserve for 14 years, and certainly the Fed uses time series analysis to look at data and to be able to forecast what's likely to happen in the future. Certainly when Alan Greenspan was chairman, he was considered an expert and sort of a wizard at this, because he would look at different economic data and be able to forecast where the economy is likely to go in the future and make his decisions about whether he should keep interest rates unadjusted or raise or lower them. Private sector companies use time series analysis and forecasting as well. When you think about auto companies, they have to decide how many vehicles to produce, and therefore they need to have some reasonable prediction of what future sales are likely to be. And so again, they use time series analysis and forecasting for this. The difference between our regression discussions and time series analysis is, in this case, we're generally looking at only a single variable, and we're looking at that single variable over time. The technical term is longitudinal. We're doing longitudinal analysis of a particular piece of data to be able to see patterns in the past and project those patterns into the future. Recognize that time series analysis and forecasting is a two-step process. First, you have to construct a model, and you have to test the level of error in that model. How well does that model predict the future based on past data? And we'll talk about that. And then once you do that, you're able to use that model and actually be able to make estimates about future values. This slide looks pretty busy, and it's kind of representative of what a lot of the textbook chapters look like. The textbooks tend to go into all of these different boxes in great detail. Certainly in the Albright, Winston, and Zapp book, they do a lot of detail in each of these, but at the end, if you get down and you weave your way through a chapter like that, it tells you that you really should do the things in blue. And I'm sort of a fan of using things that work and things that are practical. So I'd like to walk through this diagram very quickly. First, at the top are the three categories of forecasting. Now, there are many, many, many methods. A lot of mathematicians and statisticians have developed various ways to do forecasting over time. But generally, all the different methods fall into either judgmental, which requires a lot of personal decision making, and that's what Alan Greenspan was good at. Extrapolation, where we take time series data and we use statistical methods and we forecast the future. And then something a little more advanced called econometric models. And with econometric models, we are looking to see what causes these future values to occur. So we're actually doing regression-like work, where we're looking not only to look at trends and forecasts, but we're also looking at independent variables and seeing how they influence the trends and forecasts. So what we're really trying to do for our very first foray into time series analysis and forecasting is something fairly simple. we want to have a time series of observations, and we want to use that to be able to see whether it's a good predictor or not, and to predict future guidance, very simply. So we are going to focus on extrapolation as the category of forecasting methods that we're going to use, and that is relying on time series and time series analysis. Now, extrapolation, once you dig into that, you discover that there are four approaches in extrapolation for actually doing your forecast or your prediction. One's called trend-based regression. Another one's called auto-regression. Third is called moving averages. And a fourth is called exponential smoothing. Now, I'll leave it to you to read the details in your various books about these four methods. But what you'll find is that there are weaknesses and some shortcomings in trend-based, auto-regression, and moving averages that are sort of taken out of the process when you use exponential smoothing. So we're really going to focus on exponential smoothing as the extrapolation method we want to use for forecasting. Now you can see the little note I have on the left side of the screen in terms of exponential smoothing, and the reason that it's one of the better of the four methods is it says it bases the forecast on weighted averages of past observations. So it does a weighted averaging, which is a very useful statistical method. And it places more weight on the more recent observations, which makes a lot of sense because the closer your data is to now, the more likely it is to be predictive of the future as opposed to older data. And so we're going to be talking about extrapolation, time series. We're going to be talking about exponential smoothing, and we're going to see that there are three basic routines, and we'll get into this in a second, that you run. And for problems and homework in my particular class, I would like you to be running all three of these different methods of exponential smoothing. One is called simple exponential smoothing, where the data has no apparent trend, that it's just data, and you really can't easily figure out whether that data has a seasonal factor, like higher in the spring and lower in the summer, or whether it has something called cyclical. We'll talk about that in a second. And cyclical is sort of like when we have a lot of growth, economic growth, and then we hit a recession like we did in 2008, and we're sort of coming out of that. So we're in these cycles of economic ups and downs, and that's less predictable than something that's seasonal, which has winter patterns, summer patterns, spring and fall patterns. So when we use simple, there's no obvious trend. When we use Holtz, we're looking to see if there is a trend, but we're not anticipating that there's a seasonal trend. And then when we look at data using the Winters method, we expect that the data likely has a trend and is likely also seasonal. But again, as I say in a second, as I'll show you in a second, and as I said, I would like for you, when you set your data up in your statistical package, I would like for you to run all three of these different methods, and then to see which one has the least amount of error, and the error will be reported when you run these in the statistical package. And we'll cover that in a second. So recognize that the time series data has different components. The kind of data that we've looked at when we did linear regression was we were looking for trends. And we basically, I asked you to do a scatter plot and to make sure that the data has some reasonable proximity around a trend line. And so we talked about that when we talked about linear regression. The other aspect beyond the trends is the seasonality. And you can see I included a small chart here that shows different seasonal changes. Like in the chart that you can see here for timber production tends to go from very low in January to very high as we get past the bad weather, has sort of a dip in the summer, peaks again in the fall, and declines as we get towards the end of the year. And you can see that pattern repeated over and over each year. So there's a very clear seasonal trend to timber production. If you look at the bottom chart has to do with cycles, and in particular this one shows business cycles. And just recognize that for this lecture and for most of our beginning classes in time series and forecasting, cyclical analysis is generally a little too far advanced for what we're trying to do. Cycles are very difficult to predict, and making future forecasts based on economic cycles is extremely risky. So we're going to sort of stick with trends and seasonality. One more thing I'd like to mention about time series data is that generally we anticipate that there's noise in the data. There's this unpredictable movement up and down over time that's really hard to give any causality to. And so we have this anticipation of random variation, some unpredictable component that really causes our time series graphs to have this jagged kind of an up and down movement, in addition to the seasonality and cyclical characteristics. Remember I mentioned that what your first step is to build a model, and to build a model that is the best possible model for forecasting the future. There are a number of statistical formula that are used to calculate how much error we have in our forecast. And if you recall from the linear regression lectures, we talked about residual values, and that is how far our data points were from our regression line. And if you recall, we added up the regression values, the residual values above the regression line, and the residual values below the regression line. And generally in regression, that would equal 0. So we actually squared the residuals, sum of the square of the residuals, in our regression discussion, and that gave us the ability to determine some level of error and whether that error made the model not very useful. Well, we have the same thing when we talk about time series analysis and forecasting. We have 3 different types of errors that can be calculated. One is called mean absolute error. Another one is called the root mean square error, in which we actually square the residuals. And then the final one is called the mean absolute percentage error, or MEAP. Now, it's not necessary for me to dig into these formula, because most statistical packages, if you run a forecast using a statistical package, you will get your mean absolute error, you'll get your root mean square error, and you'll get your mean absolute percentage error. You'll get these errors outputted by your software package. Now, what's important is, in order for you to decide whether you want to go with a simple or a Holt or a Winter model, is to be able to compare these error values across the 3 models, and therefore pick the model that produces the least amount of error based on the data that you're using. And so this is a very useful set of tools in order to be able to say, well, I've run Simple, I've run Holtz, and I've run Winters, and I've compared the MAE for each, the RMSE for each, and the MAPE, the mean absolute percentage error for each. And based on the discussions and what I've seen, the Holt model is giving me the best forecast. And so then you go to the forecast produced by your statistical package, and you use those forecasts. And so these error values are useful from the perspective of being able to say which of the predictive methods should I use, and therefore what are my predicted values. Now the rest of my slides are very simple. This slide simply shows an example of sales data for number of houses sold over time. It's much larger than what you see on the screen, the data set, but I just wanted to show you. I'm going to give you a couple examples here. And so this is what the data looks like in its generic form. The next thing is, and if you've listened to my other lectures, I generally use StatTools because students can access that for free in the student edition. And so I've got StatTools now started with that previous data set. And if you look at the top of this slide, you'll see a option in this area here called time series and forecasting. Now I can't click on that now, but if I were to click on it, I would get multiple options, but the bottom option would be forecast. And that's the option you want to select when you're using StatTools to run a forecast. Now recognize I already did use the dataset manager here, and I've defined my dataset. And so then I can come over to time series and forecasting. Don't forget to define your dataset first. Then come over to time series and forecasting, click on this little drop down, and go to forecast, and then you'll get what you see on the next screen. Now I know this is a little harder to see. I actually took a picture of a hard copy with my camera, and the lighting, I guess, wasn't as good. So it's a little challenging to see. But what you get now is the box that comes up when you pick in StatTools the forecast option. And all you have to do when you do this is to check one of the two boxes at the top. And you want to check the box that is the observation set that you're trying to study. And in this case, it's houses sold. So you're trying to forecast future number of houses sold. So I've checked that box. And now if you look at the bottom of this, you'll see three options. Well, actually four. One's called moving average, but we discussed earlier we're not going to use moving average. So I checked the simple exponential smoothing, and then next I'll show you that I would check the Holt's exponential smoothing, and then I would check the Winters exponential smoothing. So again, for homework problems, you need to run all three of these exponential smoothing methods so you can compare the errors across each one to be able to decide which of the methods gives you the best possible forecast. Now, I'm not going to show this screen again, but again, it's fairly easy. In StatTools, you define your data set. You go to you go to time series and forecasting. You click forecast. You get this box. You check your value, in this case houses sold, your dependent variable, and you check whether you want simple, Holt's, or Winters, and you click the OK button. When you do that, you get output. This is the output for simple, and again, I know it's hard to see, but you get some very interesting things back here. In particular, you get your errors, your error values in this area here, and then you get your sales values over in this column. Now, what these sales values represent are the existing sales values, and down to where I actually ran out of data at this point here. And then the rest of these values here are forecasts for the future. The data set ended in September 2009, and so this software package is actually forecast the values past September 2009 into the future. And so these are my future forecasts. And so now I'm able to look at my error values, to see my actual values plotted, and see my future values predicted. And so this is the output for simple. This is the output for Holt's, and this is the output for Winters. And if you were to check these three very carefully, if you could see them, what you would see is that Winters has the least amount of error across all three of those error measures, and therefore Winters in this particular case would be the preferred exponential smoothing method that you would use. And so now that you've made that decision, you have your predictive model, and you can go down and scroll down in your spreadsheet, and you can see what the predictions for the future are. So I kept this lecture short. I wanted to try to weave through a lot of the complexity that you get with a lot of textbooks. I just wanted to hit the key points about forecasting. One is there are many forecasting methods. I encourage you to keep it simple, to use time series data, and to use the extrapolation method. We won't use judgmental, and we won't use econometric, not at this point in our analytical progression. Recognize that we're going to use extrapolation, but there are multiple extrapolation methods, and the one we really want to use is exponential smoothing, because it has the moving average method, and also it places more weight and emphasis on the more recent past values. And then with exponential smoothing, I'd like for you to run all three of the methods, Simple, Holtz, and Winters, evaluate the forecast errors, the MAE, the RMSE, and the MAPE, and then to pick the model, the one of those three models that has the lowest error level. When you do that, you're able to use output to determine future values. So I hope you can see by this discussion that we really don't need to wrap time series analysis and forecasting in a lot of complexity. It's not that complex, especially if you have a good statistical software package. So I hope you get a chance to try the problems, try some problems, to use the exponential smoothing tool and to see what kind of forecasting capabilities you get, which really are helpful to decision makers in many different fields and many different occupations.